Hello everybody, welcome to my amazing machine. What this is basically, it's random access memory, RAM. It has 8, let's see, I don't even know how to say it. Let's just put it in, so there's 8 slots, and each one of those slots can be set to a value up to 14. I'm not sure how much RAM that is. I have no clue actually. Yeah, but I will show you here. It's actually compact-ish. Basically there's 3 things here. There's address select, write value, and read value. Also this screen here. These 2 lights mean that it's ready to accept that, so it's ready to accept an input for address select and ready to accept an input for write value, and read value is always ready because it's always reading. So to put this in, basically you select a channel, then you can either read from it or write to it. Right now I have all of the addresses set to 0. And so let's do something. So the address select, basically it depends on the amount of power that your redstone is when you plug in 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So it will only accept values 1 to 8, and that because, you know, you're using redstone to select which address will be either read or modified. Any value above that will select all addresses at once, so you can write in bulk. And write value here, bring out some more redstone. It will accept all values 1 to 15, but it will take the value that it actually stores in the memory is 1 minus the input, or sorry, it's the input that you put in minus 1. So if I were to put 15, a signal 15 in, it would store it as 14. I just implemented that so it allows people to actually store zeros, because you can't really like send a signal of 0. So when you put in 1, it will store it as 0. So let's just do this here. Yeah, torch seems cool. So let's select an address. So basically you want this block of power to be given the, you know, I'll just show you. So if we want to select memory cell 1, we will give it the power of 1. So 1, as you saw in the top right corner, it said power equals 1, and wait for the ready light to come on. Usually it takes faster because it's used to 2-tick signals, I believe. It hates 1-tick pulses. So I just selected memory cell 1, and nothing's written to it. We can write a value to it. So let's just write 1. There you go, it's ready, and read value should show up. There you go, 1. And it'll also output it in raw redstone signal, so if you wanted to connect any machines or anything to it, you can do that. So that's memory cell 1. We're just going to leave 1 to be set to 1. Let's activate memory cell 2. So it will pull it up, and in just a second, yeah, so it's 0. Let's write 2 to that memory cell. So 0, 1, 2. Alright, wait for it to come up. Yes, now we have cell. We have 2 stored in there. Let's just jump straight to cell 8. Nah, you know, let's just go one more. Let's do cell 3. And then let's write 3 to it. So 0, 1, 2, 3. And give it a sec, it will come up. 3. So then last but not least, we're just going to keep everything else at 4. I mean, we're going to keep every other cell at 0. So yeah, let's check this out. So if we switch to cell 1, it should display 1 again after a few seconds once the display updates. There we go, 1. Let's check out cell 2. There we go, 2. Then cell 3. And it should be 3. There we go. Yeah, let's actually go back to cell 2. And wait for it to pop up, and let's just write 0 to it. We don't need cell 2 anymore. And, poop, it's gone. But we still have cell 1 intact. Let's see, yep. And then cell 3 intact. Boom. Then again, cell 2 is back at 0. Yeah, okay. One last thing before I show you the insides. This also accepts, two signals at once. So you can, in one wire here, I'll actually show you. You can actually send signals to the right value and the address select at the same time for somewhat quick input. So I will give this to you here. How should I want to wire it up so it's like the same timing for each. Alright. Alright. Let's bring this out. I have no clue how I'm gonna do this. So here, I got an idea using the new book stands or lectern, whatever it is. You can actually output custom signals here. So let's make a book. Let's make this. So we're gonna make it, just fill up a few pages here. Alright, set it on page 3. Stick that there. I believe it's on page 3, so if I were to connect raw output to this, check. Sorry, it's on page 1. Now it's on... Ah, shoot. I made a mistake. I'm sorry. I totally forgot how these worked. Alright, let's grab a new book in Quill. Whoops. So yes, it is the percentage of the book that is done. I forgot that change. So let's just fill this up here with 15 pages. Let's just do it power. Alright, put these here. So we're going to select, so it's on page 8. So it will be selecting memory cell 8. Then we're going to write a value of, let's just say 3. We actually need to go for 4 because, remember, it's 1 minus, or the value put in minus 1. Make sure these are working correctly. That is 8, and that is 4. Alright. So now in sync I will have it do both redstone signals, I guess. And I can just do... Oh, shoot. I accidentally just wrote the value right then and there. Well, that also helped me notice a flaw in my system. I am sorry, I do not pre-plan my videos. Alright, we should be good now. Alright, this is what it will be. Once both of these pistons will go down, it will select memory cell 8, and at the same time write 3 to it. So if we do this right, also just to show you that there's no trickery going on, 4, 5, 6, 7, 8. Let's pull up cell 8. And so let's actually write 1 to it right now. And yeah, let's switch off the cell. So we're on a totally different cell. So now is the time I will show you. Alright, that should have done it. Now it should pull up 8. And it's 3. So perfect. Yeah, that's awesome. Holy smokes. I did not expect that to work-ish. Alright. So now that we're getting rid of this, I will show you the insides now. Alright. Here we are. So... Ooh, spooky noises. Here's how it is. So, this input line here, this address select line here. Goes through all this, and don't just forget about this wiring. This will determine the ready signal. It goes through this, and it comes over here. It preserves the signal, as you see, and it comes over here, and it stores it in this memory cell right here. So as you can see, it stored it as 2, which is right before I got in here. That's what I stored it to. And here it is. And then this device right here will determine basically which one that's on. So now it's on 2. It turns that basically it puts down a piston down the line. So based on the signal length, so 1, 2, 3, 4, 5, 6, 7, 8. Since we gave it signal 2, it puts down the second piston, and it enables the second power cell, which is this one right here, to be written to. These memory cells here are the ones being tracked here, and as you can see, cell 8, where is it? Where is 8? Here's 8, okay. As you can see, this stored our power value of 3. So yes. Then once the address is selected, and a value is put in, it will run down that line of redstone and right to the memory cells that all the pistons are down on. And let's see, if we actually give it a value, like I said, of above 8, I don't know where to put this, so we're going to be forcing in a value 15. It will put down all the pistons because it's above 8, and now I can write to them in bulk. It also reads from them all at the same time, which only really yields your maximum value that's stored in that. I know this device can be made more compact, probably, and also can be infinitely expanded up to like 16 or whatever values you'll be putting in. But yeah, you can have infinite memory cells, and all of it can be stored up to value 16. And that's that. Also, the LCD works in the output. The output just gets the signal from which the piston's down, and it will put it down the line. It will display it out in RAW, and also will display it on the LCD here. So yes, this is a pretty cool project. It took me a few hours to actually get everything planned out. And yes, of course, all this. And these just all have one item in it to subtract one every time it goes down the line. Yeah, this is it. It's fairly simple. Not really. It took a lot of planning. But I came up with a design that's stackable to the side, so you can just keep going as far as you want down. So yes, this is the Awesomest Machine. Yes. Yeah, that's it. This is memory storage in Minecraft. So yeah, thanks for watching.